Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and today I'm going to work through a series of questions using non-right angled triangles and the sine and cosine rules to find missing side lengths and angles. Of course, being able to identify whether or not I'm using the sine or cosine rule is one of the biggest challenges when it comes to the sharper end of an IGCSE paper. So let's get going. What I've got is a non-right angled triangle here labelled ABC. Got an angle and a side length and another angle and another side length, and because I've got two pairs here of angles and opposite side lengths, I know that that's the sine rule. So that's a good thing to establish quickly, first of all, but also because the thing that I don't know is a side length, I should put my side lengths on the top half of the sine rule formula, which, as a reminder, is A over sine of angle A equals, well, in this case it's C and C, so lowercase c over sine of C. Okay, so let's substitute some values in. A I don't know. Angle A is 35. Length C is 14.4. And then angle C is 65. Okay, timesing both sides by 35 gives me A equals sine of 35 multiplied by 14.4 over sine 65. Notice I haven't touched my calculator yet. I don't need to. It's not until I've got a final sort of calculation to do for side length A here that I need to get it out. Now, to make sure that we really get this right, you see the top of the screen, that's marked D for degrees. Make sure that you go to the setup angle units, make sure it's set on degrees. It might be that mistakes are being made because of that. Now, we had sine of 35 multiplied by 14.4 divided by the sine of 65. Let's have a look here. Yes. You've got to make sure that if you're not using I don't use the fraction tool on the calculator, but I just use the division tool because that's what a division is. It seems a bit redundant to have that fraction function when you've got a division sign anyway. Make sure we have all of the brackets in the right place, and then I get A to be 9.11 centimeters in this case. Yep. That's the three significant figures, sensible thing to round it to. Okay, let's look at the next question that I've got here. It's another non-right angled triangle. This time I've got two side lengths and the angle between them. Two side lengths and the angle between them. This is side length lowercase f, this is side length lowercase g. Because I do have two side lengths, the angle between them, that means cosine rule. Okay, it means cosine rule. E squared equals 12 squared plus 13 squared minus 2 times 12 times 13 cos of the angle that we have, in this case 108. Okay, you might wonder how it is that I am able to recall that formula. This is not the first time I've used the cosine rule. That is my answer. Practice makes perfect. 12 squared is 144. 13 squared is 169. 12 times 13 times 2, that makes 312, or minus 312. And then cos of 108, well, that's scary, so let's just leave that there for now. 144 plus 169 makes 313. There we go, minus 312 times cos of 108. Have I got out my calculator? Well, yes, I have, but you won't know, well, you couldn't see it. But listen, all of that stuff I could do in my head, arguably, if I wasn't lazy. So at this point, I'm going to work out 312 times, let me get that out so I can show you there, times the cos of 108. So this is effectively the bit there. Now, because that's a negative and it's being subtracted, we can think of 313 being increased by 96.4. Okay, that might be a reason why mistakes are being made on this question. 313 minus answer. Yep, gives me 409.41. So E squared is 409.41 da 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 da. I don't want that because that's E squared. I want to square root it. So square root the answer gives me 20.2 centimeters. And that's the answer to that part. Magic. You know what? I think I'm going to keep going. I'm going to blitz through. I'm going to get all of these questions done so that I can go home. Question 7. I'm looking for angle P here. And I have all 3 side lengths. If I have all 3 side lengths and I'm looking for angle P, that's the cosine rule, okay? This one over here is lowercase p, up here is lowercase r, over here is lowercase q. So, because I have angle P, it makes sense to use the opposite side length as the subject of this cosine rule formula, i.e. 9.4 squared equals 5.2 squared plus 6.1 squared minus 2 times 5.2 times 6.1 multiplied by the cosine of angle P. That's what I don't know. Let's start figuring out some numbers here. 9.4 squared. 88.36. 5.2 squared. At this point, you have my permission to get out the calculator because these are a little bit tricky. 27.04. 6.1 squared. 37.21, and then 5.2 times 6.1 times 2, that makes 63.44. So this is subtract 63.44 times cos of whatever P is. Okay, I have to put it over multiple lines because I'm running out of a bit of space in this work, but you get the picture. Okay, let's try simplifying this up a bit. 27.04 plus 37.21, that's 64.25. So at this point, having done a little bit of the squaring and adding some numbers together, I have this. 88.36 equals 64.25 minus 63.44 cos P. Let's get P on its own then. Let's try isolating that. Good place to start, take away 64.25 from both sides. So 88.36 minus 64.25 makes 24.11 equals negative 63.44 cos of P. Okay, cos of P is being times by negative 63.44, so if I divide both sides by that, I end up with 24.11 over negative 63.44 equals the cos of angle P. Okay, so negative 63.44, put that in. Yeah, I get that on my calculator. Makes sense because it's simplified the fraction by making the numbers whole, which is quite clever. I want P on its own, so I'm going to take the inverse cos of that fraction. That will give me angle P. So, shift inverse cos of my last answer gives me the angle. And the angle is 112.3 degrees. Magic. Nearly there. Certainly getting there. Question 10. Excuse me, had a bit of a technical issue there. Thank you for bearing with me. Okay, I've got a triangle here. I'm looking for, oh, what am I looking for? Angle S, this angle here. Let me mark that on. And you'll notice that I've got 2 pairs of opposite side lengths and opposite angles. All right? Which means it's the sine rule. And again, because the sine rule is applying, the unknown is an angle that I've got, it's good to put the angles in the numerators. Okay? So, the sine of angle S, I don't know. divided by 6.9 equals the sine of 81 over 8.8. All right, exactly the same as the first question that we did together in this video. Let's multiply both sides by 6.9. We get sine of angle S equals 6.9 times the sine of angle 81 over 8.8. Okay, let's crack open our calculator and get that done. 6.9 times the sine of 81 divided by 8.8. Having typed that in, that's what we get, 0.7744. So that's the sine of S. 0.7744, blah, 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 blah. We don't want the sine of S, we want angle S, so we're going to inverse sine that, yeah? Inverse sine both sides to get S on its own. So the inverse sine of that angle is going to be 50.75, so 3 significant figures, rounds to 8. 50.8 degrees for that angle. So there you have it. Not only is it the record set for longest Maths with Mr. Duffield video yet, it's also 4 questions on applying the sine and cosine rules to find missing side lengths and missing angles. Well done for following me through that. Great work. I hope that helped you. And for goodness sake, upload your work on Teams. I will talk to you very soon.